In this video, I'll be showing you how to configure Glade and to draw some layout. So you start by downloading and unzipping Glade into a directory and sticking it someplace convenient. In my case, I just stuck it on my desktop, and then you double-click on Glade, and we'll maximize this window here. And so here you have, down at the bottom of the screen, you have a little message window, which is effectively like a little Python shell window in which messages will be displayed, and you can actually execute Python code at the little Python prompt there, which is kind of a cool thing. And then you've got some toolbar up here, and you've got a second toolbar that has some shortcuts for things that are also in the menus. And the first thing we're going to do is basically show another couple of things here. Under Tools, we're going to want the LSW, which is the Layer Selection window, over here on the right. And this will be where we select layers that we want to draw things on. And then we're also going to show the library browser, which will show us what libraries we have open over here and the cells inside those libraries. And so the first thing we're going to do is create a new library. So File, New Library. And I'm going to call this library Buffer Example. And we're going to browse for a technology file. So the technology file lives in the ENGR3426 zip file that you'll download off the course website. It's called C5N, which is actually the name of the technology that we are using. And it's got an extension of .tch, which is a Glade technology file. So we attach that, leave this database units per micron at 1,000, and just click on OK. And so now we have a buffer example library. And what we'll do is create a new cell. So it's File, New Cell, and we're going to call it Inverter. And click on OK. So now over here you can see all of the layers. There's NWell, Active, Poly, NSelect, PSelect, Poly2, and so on. And this is going to be our layout window here. But we need to do a couple of things to properly configure Glade to be able to draw on a grid and all that stuff. So go up to the View menu and pull down to Display Options. And we're going to have to set some things here. So the first thing we want to do is go to the Display Settings tab, and I like to have my grid displayed as dots, and I like to set my grid up to have major grid points every 4 minor grid points, and the minor grid points we're going to want to have on a 0.3 micron grid spacing. So change the X and Y from 0.1 to 0.3. Go to the Snap Settings tab, and we're going to want to snap to a 0.3 micron grid as well. Please do not draw things on anything finer than a 0.15 micron grid, which is a half lambda grid. Otherwise, you will create all sorts of headaches for yourselves. And I would leave the snap angle to basically 90 degrees. And then there's one more thing we want to do, and that's go to the Miscellaneous tab, which is hiding off to the right there. And we're going to want to uncheck this box that says Always Pop Up Option Dialogues. So this is going to be more convenient than to have that always pop up. You can always toggle those option dialogues on and off using the F3 function key. And so we may do that a couple of times during the course of this tutorial. But I think by default having it off is a good thing. Okay, so you click on OK, and there's our grid. And so you can pan using the arrow keys. And there's the origin of our cell, and you can see that the little box cursor there snaps to our 0.3 micron grid, and we have a sort of a brighter dot on every major grid point, every 4 minor grid points. And so there are a couple of ways that we can start drawing things. The first thing to do is select the layer that we want to draw in this case Active, and you can go up to the Create menu, and you can find all these different things you can create. Primarily, we're going to be working with rectangles. That's when I draw layout, I typically just draw rectangles. But you can also create paths and all sorts of other things. So to draw a rectangle, the most convenient way of doing it is to know that the shortcut key is R for create rectangle. And so what you do is you select the layer you want to draw in, active. You put the cursor where you want to start the rectangle, you hit the R key, and then you basically draw the rectangle. And you finish it off by clicking the left mouse button. So I want to make it 6 tall. So 1, 2, 3, 4, 5, 6. And then I'm going to make it 14 wide. So 6, 2, 1, 2, 3, 4, 5, 6. Okay, and I'm going to draw a contact cut. Just 2 by 2, so I'll put the cursor there, draw a contact cut, draw a contact cut over here, and now I'm going to draw some poly. There's my poly. So that's effectively a transistor, although we're going to have to put select around it and put metal over the contacts and things to make the whole thing. But this is going to be my NMOS transistor, and I'm going to want to extend this over to make a merged contact here. So the convenient way of doing that is if I left click on something, you can see the whole box is highlighted. And right now I'm in what's called full selection mode, where when I click on an object, it selects the whole thing, and I can move it around and copy it and things like that. If I want to reshape it, what I can do is I can hit the F4 key, F4 function key, and that selects, sets the selection mode to partial, which means that I can click on an edge of a box, and I can hit the S key to stretch, and then I can basically stretch it. 2, 3, 4, 5, 6. Okay, so I've made my active region a little bit wider here, and I'm going to change the selection mode back to full by hitting the F4 key. It's a toggle. I'm going to select this contact cut. I'm going to make a copy of it. I can do that by selecting that box and hitting the C key for copy. And now you can see I can move that around and make a copy where I want. So I finish that off by left clicking to put it down. And if you select more stuff, you can copy a whole selection at a time. So I'm going to draw a box in metal 1 for the connections between those. I'll draw a box in metal 1 around this. And I'm going to draw some, actually, why don't I copy this whole thing before I put the selects in. So I'm going to select area, select this whole thing. Again, hit the C key, and I can basically put that whole set of geometry down. And I'm going to want a 12 lambda spacing between these two actives. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How about that? Doesn't always happen that way. I'm going to delete this piece of poly by just selecting it, hitting the delete key. I'm going to delete this piece of metal by selecting it and hitting the delete key. I'm going to switch over to partial mode by hitting F4. And I'm going to stretch this metal 1 line to make my drain to drain connection. And I'm going to stretch this polysilicon up here to make my gate-to-gate connection for my inverter. So this is going to be my NMOS transistor down here. This is going to be my PMOS transistor up here. And now I'm going to put in some selects. So I'm going to put N select around my NMOS transistor. Has to surround by 2. I'm going to put P select around my P substrate contact. And so we have here a merged contact between my P substrate contact and my N plus source diffusion area. We do a similar thing around the PMOS transistor, only with the opposite type of select, so the P select goes around the transistor in this case, because it's a PMOS, and the N select goes around the N well contact, because it's an N well contact. And now I'm going to draw my N well, which has to surround the active by 6. So there's 2, and another 4, and then 1, 2, 3, 4. So there's my N well. By the way, if for some reason I didn't want to have this N well rendered so that I could see better what's going on underneath it, I can come over here to the layer selection window, and I can right-click on a layer, or I can middle-click on a layer. So middle-clicking on it makes it not selectable. Right-clicking on it basically hides it. And so sometimes you'll want to hide a layer so that it's still there, but you can see what's underneath it better. And so you can toggle that with a right click on the layer selection window. I guess I should also mention at this point, if you click on this little stipple pattern here with a left click, you can actually change the color. And if you right click on that little thing, you can change the stipple pattern. Please don't do that. It's hard enough looking at layout, but if you start making random color schemes, instead of having a nice uniform color scheme that everybody adheres to, it's just not going to be easy to understand what's going on. So please, even if you don't like the color scheme, don't change it. I will not be a happy camper if you change it. Okay, so we have here our transistors and some of the connections. Now what we're going to do is basically put in a little stub of metal to take the output here off to the right, and some metal to bring the input in here from the left, and a poly contact here. So let's start out with our metal. I'm going to create a rectangle. Takes that out to the edge of the well. And we're going to create a rectangle on metal 1 to bring the input in here. And we need to be 3 away from this metal. And so we're going to draw it to there. I'm going to make an area for the poly contact. So I need to make this 5 wide. 2, 3, 4, 5. Put a contact here. It's actually kind of hard to see that contact cut. Actually, maybe I'll switch back into full selection. Actually, maybe I will use an actual poly contact for that instead of a generic contact. That's probably why I made poly contact that color, so it shows up better. All right, so now we're going to make our metal 2 lines for a VDD and ground. So we're going to put in a couple of vias. We're going to use stacked vias on top of these contacts. And then we're going to use metal 2 for our VDD and ground rails. Okay. So aside from maybe making some pin labels or net labels, this is our inverter layout. And at this point it might be a good idea to do a design rule check. And we can do that either by just clicking on this little tool up here in the toolbar, Run DRC, or we can go to the Verify menu and pull down to DRC, Run DRC. Or you can hit the D key, which is a shortcut for Run DRC. The DRC rules are basically contained in a Python script, which is C5N_DRC. So we run that, and it show some output down here in this window, so you can see it says checking for off-grid geometry, checking for bad contacts, and so on and so forth, checking for all these different rules. And in this case, it says no DRC errors were found, which is a good thing. If we were to do something like maybe move this box here over by 1 so that we have this metal only 2 lambda away from this metal, and we were to rerun the DRC, we would find this little DRC marker, error marker, which shows us that we have a design rule violation, and you can actually bring up a little dialog here and step through all the DRC errors with a view errors dialog. You can see metal 1, rule 7.2, metal 1 spacing greater than or equal to 3. And so you can step through all of the different DRC errors, you can delete the individual markers once you've visited them, or you can just clear all the DRC error markers and resolve the errors and rerun DRC. So we'll move this back over. And so what I'm going to do now is basically create some pin names, and you can do that by using the metal 1 pin layer and the metal 2 pin layer that are down here a little further. These are metal 1 and metal 2 drawing layers. So the metal 1 and metal 2 pin layers and the metal 1 and metal 2 net layers are basically for labeling pins of a cell or nets for intermediate nodes local to a cell. So what we're going to do is, let's say select metal 1 pin, and we're going to put the cursor somewhere and hit the T key for create text. We're going to call the output here vout, and by default the text appears kind of in a certain position relative to the cursor position. You can change that with this little pop-up menu here. I think I want it to be I believe center left in this case, and I'm going to create text here. It's going to be VN. I would like for it to be center right. VN. Switch to metal 2 pin here. Create text. This is going to be, let's say, vpause. These parallel what we did in the schematic. Again, center right. And we'll do vneg here. Need to hit T, vneg, center right. Okay, that's our inverter cell. So let's save the library, and we will browse to put this in our engr246 directory. Desktop engr3426, select the folder, and it will save it there. Okay. So at this point, what I would like to do is to create the buffer cell, which will have instances of these two of these inverter cells in them, connected together just by putting them next to each other. So we're going to create a new cell. File, new cell, call it buffer, and we're going to create an instance. So I think that's I, but I can never remember, so yes it is. I is create instance, but you can see that we're creating an instance of buffer, and it's not going to let me do that because that would be sort of a circular reference. But if I hit the F3 key and bring up that option dialog, you can change the cell that you're creating an instance of. So I'm going to change it to inverter. You can see now I'm creating an instance of cell inverter. Now if I wanted to, I could make an array 2 by 1 in one shot, which I'm not going to do in this case, but I would put that here in this dialog. So I can make a 2D array or a 1D array by changing the number of rows and number of columns here. I can change the spacing. By default, it probably is the bounding box of the cell in the horizontal and vertical direction that I'm creating. But in this case, I'm going to make 2 separate instances. So we'll hide this dialog now that we switch that over. And put my first instance here. create an instance again, put that down next door, and so you can see I've got my two inverters, and here's my buffer overall. I've arranged things so that things are connected just by abutting them. And so at this point it might be a good idea to do a design rule check so that we're sure that we don't have any DRC errors at the interface between the two cells. So I can run DRC, and there are no DRC errors in this case. And now what I'm going to do is I'm going to make some metal stubs in the cell that would be used to route signals into my buffer maybe. So I'm going to make a little stub in metal 2, or metal 1 rather. The input for the output, and for the power supply connections, and now I'm going to create pin labels for this cell kind of at the edge of these stubs. Again, metal 1 pin, create text, call it out, and let's do center left, and we'll do a similar thing over here for in. Make it center right. Switch to metal 2. Text. Pause. Center right. And text. Neg. Center right. Okay, so that's my buffer cell. Can zoom to fit and save this.